started this standard yesterday. Mathematics 9 through 12, functions 2.1. Identify the effect on the graph after replacing f of x with f of x plus k. And of parentheses x plus k. Y'all cannot drop the word. Okay. So yesterday I said a number after the function notation. Would this shift the graph up or down or left or right? That's the shift up down. Yes, since it's plus, maybe you want to say it. Oh. But it's just symbolically a number after the f of x means that's gonna, and it's so you're supposed to be able to identify the effect of the graph. So I'm telling you, if you put a number after your function, it moves it up or down. This one, if you put a number in the parentheses with the x, that shifts it. That shifts left, right, okay? And that is a summary of what we spoke about yesterday. We practiced slope. Listen, Jay, I'm doing a whole thing here. If you know why, yeah, okay. I did a summary of a slope and y-intercept, and now I'm moving forward on that and showing you how to move those up and down and left and right. Now this one is a change in this one, but it's changed a little bit different than how we changed them yesterday. A lot of students get tripped up on graphing y equals x because they don't see any numbers. The numbers are invisible, but they're there. What is the slope of the graph y equals x? 1 over. It's an invisible one. Good job. There is an invisible one there. And what is the y-intercept? It's a 0. So there are numbers there. They're just invisible, which I think is so annoying. Like, why do we gotta make numbers invisible? So we're talking slopes and intercepts, and when it comes to y equals x, they are there. But it should be shown rise over run is 1 over 1, invisible, and y-intercept is 0. So you start at 0, and you go up 1 over 1, up 1 over 1. So you can do this right in your color, right on your notebook paper. You're going to make an x and y axis. You start at 0, and you go up 1 over 1. You can do it in notebook, that's okay.
Which goes the bathroom?
So, yeah, you asked first. You still want to go? So you can go, but you want to go? Yeah, Colton, he's probably over there. I don't know, comfortable there. Thank you. So I'm going to introduce to you a new word for this. This graph that goes through 0, 0 has this little regular old slope of 1 over 1. It's actually the most basic linear function, and mathematicians decided to call it, since it just has 1 and 0, they call it the parent function. It's the parent. It's the most basic one. All functions have a parent. And they call the function a function family. It's cute. And then the transformations that we started yesterday, those are just transformations of the parent function in the function family. So this guy here is the most basic linear function, the one that goes through 0 and goes up 1 over 1. So you're challenged to then graph y equals 3x. It also has a 0, so you start at 0. And if you want to do this one in a pen or a highlighter so it looks different, you're putting it on the same coordinate plane. So if you want to use a colored pencil, you can. Make it look nice. That's up to you. Maybe you want to do them both in pencil and then highlight over it. That's good too. So we're starting again at 0, 0. But this time we're going to rise 3 and move to the right 1. Guess I'm doing it here. I'll do it in green. Start at 0, 0. Count up 3 over 1. And I'm going to follow the pattern the other way, which I know is more challenging. There it is. At 0, 0, yeah. Okay, I'm hearing an observation. These do cross at 0, 0. That's called a point of intersection. Let me ask you this. Is the green line, is it shifted up or down? It's actually not. It's in the same spot. Is it shifted left or right? No. So this isn't what we did yesterday. This is today. This is called a stretch. This is called a vertical stretch. So if red was pulled on by some force, it would become green. It's taller, it's skinnier, it's been stretched by a factor of 3. So when you put a number in front of the function, that's called a vertical stretch. So I'm going to write that out when you do it too. The vertical stretch of 3. Yesterday I used the word steeper. We talked about how many different ways we could spell steeper in the English language. There's lots. English language is confusing that way. Oh, that's the answer to number 3. I should have written that for number 3. Describe the transformation. That's called a vertical stretch of 3. Now, I've been changing my mind between 5th and 6th period, but you guys, I assigned 1 through 6 in the book yesterday, right? Let's look at those answers. This is page 259. Just do it right now. It's easy. Shh, you gotta be quiet. Shh, be quiet. Right. Yes? Yeah. Alright, so it says use the graphs of F and G to describe the transformation. So it looks like in the pictures F is black and G is red. Didn't I do 1 and 2 with you yesterday? Yeah. Okay, I'm gonna go ahead and say it here. Red is up 2 from black. Are you okay with that? Red is up 2 from black. Ashley, and number wait a minute. Is the red the new one? Yeah, G is up from black. Alright, so in number 2, Ashley, red is what from black? How would you say? How is red different from black? It's hard to see, right? So I gotta focus. So here's red. I think it's easier, but I don't know what you think. I've seen this so many times. This is brand new to you, so you guys need to tell me. I think it's easier to understand that if it's in parentheses, that means left, right. I don't know if you guys are on board with that. So when I look at black, I see red is How far over? It's 1, 2, 3, 4. Red is 4 units left of black. Can you count that and see that? You can also, without the equation, you could describe red from being up from black, and you would be right. It looks like it's either to the left or it's up. All right. Number 3. So they're no longer giving us a picture. We have to go off this. If our function is 1/3 x plus 3, and they're telling us to put a minus 3 at the end, Rigoberto, what do you think that is? We're on number 3. Well, let's think about a minus 3 at the end of a function. How could a minus 3 at the end affect a graph? It's going to affect the y-intercept. Specifically, what will it do? Aaliyah, what do you want to say? Yeah, tell me what it is. Yeah. Yep. This is a vertical translation of -3. A lot of you guys knew it. Good job. You want to try again, Rigo? What do you think the +1 does? No, man, it's still vertical. Vertical translation of 1. All right. Got it. I'm in it. Okay. Now, how is the 5 and 6 are different than 3 and 4? Megan, what's 5? How come, Colton, how come in 3 and 4 I wrote vertical and now in 5 I'm saying horizontal? Because it's in parentheses. You guys are in this. Okay. So then this one would be horizontal right 3. I do too, but you know what? It's opposite of what I think. Yeah, it's opposite of what I think. Ashlyn, what are you talking about? Did you get it right? You got it. So you're ready to move on. Let's move on. Get your hand out. Let's move on. Let's move on. All right. You guys, be quiet. Be quiet. Listen, I will shorten this, and then you guys can get right into big ideas math, and we can be silent. Okay? We don't have to do all 6 of these. I'll do 3, and I'll try to do them quick, and then I'll stop talking, and I'll watch you guys be silent. Okay. Skill number 3. Understand reflections. Reflections are also known as flips. Raise your hand if you were absent yesterday. Good job, you guys, coming to school. Very good. That's half the battle. Being here, I think, is actually more than half the battle. It's a lot of the battle. Okay. All right. Our parentheses say a negative sign in front of f of x will flip a graph across an x-axis. So, just like yesterday, start with graphing f of x is 3x plus 4. We graphed this yesterday, so I hope everybody feels capable of graphing this today. You're going to begin at 0, 4. And go up 3 over 1. That's rise 3, and then move to the right 1. So this lesson is it's new, but it's actually disguised as a review for everyone who still needs a little help on these lines.
So, look at the rules. First of all, you're gonna want to plot every single time it goes through on both sides. You have to plot all the
Got it. Okay. Now, what do we do about this negative sign in front? Yeah, we're gonna change it negative. It ends up being distributed. I'll show you the math behind it. I would take, instead of 3x plus 4, because of that negative sign, I'll put a negative sign outside the whole thing, and I'll make the whole thing negative. I'll distribute it in. It goes here and here. So my new function, which they're telling me to call the new one g, is negative 3x minus 4. And then you regraph that one, and it should show up as it's being flipped. Like if you fold the paper at the x-axis, it should be flipped over. So give it a go. Start at negative 4. Now I'm down at negative 4. And then we have negative slope, which is where we get it wrong. It's right here. Do you see it there? So that negative sign is like a negative 1 that you multiply it. Good question. Who else has a question? You started at 3. You started at 3? No, you put it. Oh, thank you. Thank you. Good eye. It's hard to see. 1, 2, 3, 4. Thank you so much. All right. So to graph this one, of course, the negative slope is more difficult. But what I want to do is I'm going to fall 3 units and still go right 1. Okay, since it's negative, I count down and right. Down and right. Starting this time at the negative 4. Down and right. Like, how come you're not eating at lunch? So, yeah, we're going to feel it. You're going to have to stop, okay? It's too far behind. 1, 2, 3 to the right. 1, 2, 3 to the right. 1, 2, 3 to the right. 1, 2, 3 other way. 1, 2, 3 other way. Other way. Other way. There it is. That's a reflection. It's been flipped down. That's pretty cool. Yes, that time I started at negative 4 because that negative 1 got multiplied and it changed both of their signs. This one's what you do next. You start at negative 4 and fall 3 and go over. Change the whole thing negative. Now, if it had started negative, it would have changed it positive. Because we really should practice negative slopes as much as we can. So we're graphing negative 5 over 4x plus 0. That's our f function. Start at 0. And this means 5, and we move to the right 4. Start at 0, and since it's negative, fall 5, but still go right 4. Fall 5, right 4. No, it'll just be positive 5 over positive 4. So now to perform the transformation, the negative in front, it's negative 1. Who is that? Yeah, don't open the door if you don't know. Come on, that creeps me out. Your window. Yeah, the window knocked. That was different. Yep. Okay, negative 5 over 4. X. Okay, so now we got a negative 1 times a negative fraction. That's going to become positive this time. So now it's a positive 5 over 4x. So now you go up and right, up and right, rise over right. Starting again at 0, up 5. Now we go right.
Up 5 and over 4?
Yeah, up 5, right 4. It's positive this time. We don't fall, we go up. No, go up 5 and right 4.
X marks 0.
This time it's a 0. There's no number.
Calm down.
All right, there's only one more transformation to cover. The bottom half of this. Let's just do one more. Are you guys good? We ready? We ready? Not yet. What is it? Strengths and stretches. Stretching. I understand the stretch and the strength. So a number multiplied outside of f of x will stretch or shrink the graph. If the number is greater than 1, then it will become more steep or stretched. If it's less than 1, then it'll become less steep or it'll become flatter. So number 10, we're going to graph this one. For f of x, you're going to begin at 0, negative 2. And your m is an invisible 1, so you move up 1 over 1. Well, I think we have to try again. Is that the last one?
Please.
You can say Melina.
Yeah, I just think Spanish. I can do a really good country accent. I can even sing in like some random Russian songs. That's really funny because they get played on my For You page. And then like that. And that's you. Christmas song.
Okay. So now to make H, you got a 4 out front. You're going to distribute that 4. So it's 4 times x minus 2, which would make it 4x minus 8. And that's our new structure function. You distribute the 4 in the g function. Nope, we're calling it h this time. The function Henrietta is 4x minus 8. So we begin down at -8. And we count up 4 over 1.
I don't want to feel you down.
That's fine.
So we're going to do this last time. God help you if you have a question. Do you think anybody could tell me what the h function would be on 11? Like, we're not going to graph it. Like, could you tell me out loud? Yeah, what would it be on 11?
Like the equation, it would be 1/2 distributed 4x plus 50.
So what would it be? 2x plus 1. And then number 12 would be -20 over 4. So it would be -5x. Alright, you guys can go ahead and log into Big Eddie's Math and start your assignment.